What is in your firmware? That's what this video is going to answer when we do some static analysis on router's firmware binary. So we're going to take a binary, we're going to run a tool on it called Binwalk to extract, and then we're going to dig in, doing our best Sherlock Holmes impression, digging into the root file system, see what files are run at startup, see what files are connected, and maybe see if we can't find any vulnerabilities where we could maybe dump into Ghidra in a future video and see what we can find. But in this video, we're going to go under the hood and look at some router's firmware via static analysis. So without further ado, let's just jump in. We have Kali already loaded up. Let's take a look at, do a little ls on this. We're going to be taking a look at this at TP-Link firmware. So as I mentioned, I already have Binwalk installed. This is we're going to be taking a look at version 2, which has end of life in 2025. There's also a v3 that's written in Rust. I also have that installed in Docker, but for the purposes of this video, let's just take a look at with the normal Binwalk that we have, or v2. And so with that, we do Binwalk TAC-E, TP-Link, and then we don't have to worry about the warnings here. What we're taking a look at is we have this compressed data, and then also we have some information about this squash fs file system. Now that's the root file system that we were just talking about a second ago, or that I was mentioning. So let's go ahead and take a look at what gets created by Binwalk. And what gets created is this extracted directory. So what we're going to do into that is go ahead and change directory. Now let's see what's in there. And as we see, we do have squash fs root and then a couple other files and directories, but the one that we want to deal with is this squash fs root. So let's go ahead and take a look. And as you can see from here, this is normal Linux directory environment. And what I like to do when I'm taking a look at firmware for the first time is going to be take a look and see if maybe there's any startup scripts or anything along those lines like that. And typically what that is done, or where that is located, is going to be in the etc folder, which hold the configuration files for this router. So if we go ahead and change into that, let's just take a look at what we have in there. Alright, so we have init.d, which is what we're going to be actually taking a look at. This password is right now to def null, and then there's also password.back, which is a backup file, I'm presuming. And let's just go ahead and, just for purposes of this, we'll clear the screen. And cat password. And nothing. Dev null. So we don't have anything. But let's just take a look at that password.back and just see what that, because that's interesting. Now we have admin username and then a hash of the admin's password. Wow, now that is something. But that's not the end of our analysis. But wow, I already found password hash that potentially you could crack, a tool like Hashcat or anything else, and take a look at, and if you fire it up, you could maybe SSH into it, or that type of these different items. So this is interesting. We're gonna, if you're taking notes in something like Notion, drop that in there. But let's go back to what we were talking about, because I said I wanted to take a look at the init.d. Alright, so ll-l. Okay, So we have this RCS here, and what that is basically a run control script that's executed when this is booted and provides information about the operations performed during the boot process. So this is something of huge interest, and let's just go ahead and take a look at that. And what we can see here is if we go up to the top, well, we start seeing shebang. Let's see, we're going down, and what we have, which is interesting here, is we're copying whatever's in var password, or we're doing a copy operation. And what this is doing, which is certainly done before any of the static analysis is done, this is executed again during boot up. And yeah, it's something that is really interesting, and that's further analysis that we are taking a look at from that purposes. Let's go back. So again, we're putting this into our little notes here, and again, I want to move up one level and take a look at what other items are here. Ooh, this reduced data model XML is something that's interesting. Default fig .xml, that's interesting. That is something default, I'm assuming default configuration. So let's go ahead and just cat that. But as you can see, this is all gibberish. And what that is telling me is that this has been encrypted, and something that we would need to find the encryption key for, something that hopefully we would be able to further investigate, and that's exactly what we're going to be doing. So as I mentioned, yeah, we know we need to get the encryption key for that. How do we do that? That's a very good question. So we're going to move up one more file, and what we're going to be using is, I like to use grep, but you can use something similar with find. But if you see this right here, what this is, this TAC-L option is only going to show files with the keyword decrypt. And once we do a decrypt on or grep, I did a little bit of analysis beforehand, but this is going to be the file that we're interested in using, and that we're going to be dropping into Ghidra and taking a look at for the purposes of seeing if we can't get that encryption key, because this includes some type of decrypt function. But that doesn't end our static analysis today yet. No. Let's go ahead and change to lib. And we're going to go ahead and clear this screen. Let's do a little bit of analysis on this, which we can do with something like file to see that it's a shared object file. MIPS 32. So that's some additional information that we're going to be able to include in there. We can also take a look at readelf, and that'll give us the magic header, confirming that this is a MIPS 3000. Start of program headers, section headers, the size of the header, and it just gives us, again, some additional information with regards to this, and really being able to dig into some of the other just items. One of the other items that I wanted to do as well is going in and taking a look at the symbol table, which we can still do with readelf. If we do -s lib, sorry, had a little error there. And so we get a look at all of these different function names, a lot of router, a lot of stuff in this shared object file. Stuff that would be nice if we could maybe take a look at and maybe pass through and see if there's anything like crypt or decrypt, or let's just keep it simple with decrypt. And there we go. We have at least two functions where their names include decrypt, and let's just go on the other side here, and now we actually have something with regards to crypt as well. So this tells us that this is going to be a file that we want to take a look at and potentially use, take a look at the vulnerability for the encryption key or decryption key. And so we were able to figure out that it involves, looks like AES, and a lot of different other pieces here. So make sure to hit like and subscribe so that you get alerted when the next video goes live, and we'll see you next time.